we talk about a lot of many things, and we'll see what are the core areas we have in that, like how the data processing trends have been changed from previously and current in the future, and where data science is going to play. What do we require in a data science? Or if you are becoming a data scientist, what could be your roles? What are the technologies? There are a lot of myths in the industry that mostly people think that, okay, the data warehousing, data science, whether do you have a correlation or can data science go independently, or what are the tools we require? What could be your roles and responsibilities? Hopefully, this session will clarify you, and it will set an expectation to you that like what are the technologies you need to understand, learn, and then what will be your job opportunities and what kind of expertise is required for you. So to start with, generally very high level, when we are talking about these core technologies, so mostly right, people start with the big data, and then other side people will talk about data science. And in between nowadays, we are talking lot many things about this Spark as well. Okay, now we'll understand where Spark will come, big data will come, data science will come, what other technologies also will be there. And other very important aspect, people will talk about analytics. Big data analytics, data science, what is the correlation, we'll understand. And Spark is core technology, it's a software. So I am not supposed to keep Spark here. Just to highlight the technologies, I am keeping this Spark here. Okay, so the moment when we talk about, I am initially starting with the big data, and the moment when we talk about big data, initially 5 minutes I am giving a background on big data, then we'll move on to other side. So when we say big data, the moment when we talk about big data is not a technology. You will not find out any software by name big data. It talks about some concept and it talks about some business solutions which is specific to some key areas, and it is a logical or it is a virtual concept actually, but we will not find out any software by name big data. But what big data does, very high level, big data talks about three major things which currently industry facing in challenges, and for those key things big data is going to provide some business solution. What are those three things? Very high level. So very famously, when somebody say about big data, we can just simply say big data is all about solutions related to three V's. That is very common. Everybody knows. That has become a basic apple banana kind of thing now. Everybody knows about that. What are those three V's? Volume, variety, and velocity. So I am not going to talk about too much on this one because you already know it. What is volume is? In older days we used to have data processing volumes around some MBs, GBs, and TBs. And currently whatever technologies we have available, generally data processing means immediately comes into mind RDBMS database, and these databases can support data processing up to few terabytes very easily, and even there are some specific databases like Teradata and IBM Netezza, Greenplum, and these technologies are very well equipped to process or support data up to some terabytes very easily. It's a very cakewalk for them to process it. But what if it goes beyond? The major challenge is that in that the volume, when volume grows, we need a software to support that much volume. Up to terabytes we have equipped. And also even if we are using those Teradata and then all these technologies, the cost is very high. So that is the reason big data is going to solve your volumetric problems in terms of, if you have some infinite volumes also, you have gigabytes, petabytes of X number of data, infinite data also, your big data is going to solve your problem with cheaper cost. The very tempting factor for the company chief technology officers or CEOs. Okay, when the volume is very high, even though there are some technologies available to support it, still people are going to big data. The reason is cost. It is because whatever solutions, whatever softwares we use in big data, most of them are open source. So we don't need to pay any licensing cost for them. So that is, even though they tell that I am going to big data, but internally they will always look out cost only. The internal tempting factor for the company CEOs, CTOs is cost actually. So cost is very cheaper, and also it supports infinite, up to support infinite, because the internal technology, how it supports and all that we'll see in a regular class. In case big data, not big data, you can ignore it. The second one is variety. What is variety mean? Okay, while I am talking theory, so just to give you a graphical representation, maybe you can just have a look at this. So the second one is variety of the data. What is variety of the data means? In older days, we used to process only structured data. Structured data means you will have some rows and columns. Even RDBMS, okay, row column. Even if I keep data in Excel, even if I keep data in a text pad or anywhere, only structured data will be there. Structured means if I tell you, I can, if I go to one cell, I can pick up, I can tell you to which column it belongs to, what is that information. But nowadays there is a lot of unstructured data, semi-structured data is in place. Okay, because of the various technology introduction. So we are currently a lot of technologies working on a web services. They generally prefer data in a story in terms of XML, JSON. So these are the very best example for semi-structured data. If you go to XML, you cannot find out a row or a column. It will be like everything I can, using some software I can pick up what is the column, but by looking at you will not find out any row or any column. Similarly JSON. So these are all very famous semi-structured data. And not only that, nowadays we are depending more on social media, and then we have a lot of technologies which are generating data in unstructured format. Like if I give you one voice file, audio file, video file, or image, or if I give you one plain Word document, say if I'll give you one Word document where some paragraphs are written, and then if I ask you, please find out a particular word apple, how many times it is repeated. Can you get it? If it is a skill, I can write a query, select count star from the table where column name or value equal to apple. But if it is a Word document, can we get it? No. So that is unstructured. Means unstructured means you will not have any properly defined structure for your data. But nowadays we have a lot of demand coming for semi-structured and unstructured data. But the problem is, the second B problem is variety. We have normal, all RDBMSs can support only structured data. Some RDBMSs supports semi-structured also, but there is no technology straight away supports unstructured data. But your big data is going to solve it. You give it, you name it something, and then have a solution in the big data. Though it is a structured, though it is a semi-structured, and though it is a unstructured. For all of them, we have the capabilities in big data to process them. And velocity in a simple way, rate per change. In older days, if you take a bank example, per a second, how much data generally banks generate through ATMs or whatever it is. Maybe some maximum 1 MB data or something. And even if I take any like a web blogs about any, let's say go to Amazon, at a given second, imagine some million people are connected to Amazon and clicking. If I am capturing every click of that Amazon, which is known as clickstream data, weblog data, that is going to be some terabytes and all that. And even if you take any scientific or if you take any machinery, let's for example, there is a everyday like a lot of we drill petrol from oil and gas energy plants from the sea. Every machine when it is running per second, it will capture all the weather and then forecast it, how much pressure coming from the well and then outside, internal, external, all the data the machines will capture and then give a throw output to the outside. If you take per second, how much data comes? Very, very huge. In older days, per second, data used to come very smaller. We have a lot of technologies to easily capture them. But here now, we need a software equipped to capture XYZ or infinite volumes of the data per second, and still we should be in a position to ingest and then store it. Earlier, the very regular, with the normal regular technology is not possible. Big data will provide solutions. So that is the reason generally volume, variety, velocity putting together generally simply it is big data. Means wherever you have a challenge in terms of any one of the three, big data is going to give you solution in very cheap. And you can ask me like, do we have any other softwares also? It might be there. Means if you ask me like, do you always need a big data? If you have some software, you can use it. It's not. I'm not saying that okay. Always you have to go with the big data. Maybe there might be some technologies available to support any one of the options. But with the big data, we can make things faster, cheaper, and effectively. So that is the major tempting factor here. And apart from that, in the older school, okay, big data means, okay, this is the only three things: volume, variety, velocity, in a simple way. But all this will get it in a very cheaper cost. But nowadays, there is a redefined definition for big data. Even when we say big data, there is no textbook or there is somebody not given. We only define ourselves. There is nobody properly given that big data means 3 weeks we have to define that way. So a lot of competition. IBM will define something, Oracle will define something, and then Hadoop, Apache will define something. Depends on our expertise, depends on our perception, we can define our own thing. But nowadays, people, IBM is doing a lot of things on this big data world. So slowly, since the usage of big data has been slowly changing, so that is the reason. So they have been added 3 more V's to big data definition. It's not like you have to remember, just for information sake I'm telling. So one is veracity, visualization, and then value. Even some people say validity and then volatility. Okay, all these things we'll understand now. Okay, but that is the standard old school definition. But the current big data school definition is has been added 3 more. This is more of realistic and then real time implementation point of view. These things. So these are all more of the infrastructure point of view. Volume, I need a big infrastructure. Variety, support, and all. This is in terms of the data processing. Okay, that we'll discuss later because I am not going to detail on the big data now. That's the reason I am not focusing it. Okay, so all this is in a simple way we talk about the big data. So in overall, when you say big data, what we are talking about very high level is one is storage. We need to have store. We have a support of infinite volume storage support. We need it because we don't have proper technologies to support it. And then processing and then doing something. But big data, as I told, it is a very concept only. We don't have anything. But who is going to solve this problem in big data? So there are n number of technologies, but here we have a special software called Hadoop. This is initially this is the brainchild of Doug Cutting, who is the inventor of Hadoop. Okay, and internally there are a lot of components technically inside. And the influence, what is the influencing or which is influence to develop big data? And Google has something called Google File System GFS. Based on that, the Hadoop concept has been built. And the guy who actually worked rigorously on this is the guy, Doug Cutting. This is a small team of people who actually worked on Hadoop. Okay, and Hadoop has a lot of technology. The college guy who's standing here, this is the guy who actually invented Hadoop. And couple of technologies, but later a lot of have been changed and new technologies have been added many things to this one. But this is the starting point actually. So now when we talk about big data, what are the core things we have? First thing is we should have a support of storing infinity volumes and processing. Okay, so in Hadoop, we have something called, so when you divide your tools into different things in Hadoop, the first thing is from the storage point of view, Hadoop has something called HDFS, which is pure storage. Hadoop distributed file system, which is meant for storage, and you give me 1 TB, 100 TB or gigabytes or XYZ or infinite volume, and HDFS is going to help you to store the data. So from the storage point of view, and in Hadoop we have a component called HDFS, and which will store the data 100% in a files. The storage mechanism in Hadoop in HDFS is always in the form of files only. Everything which you store in information which is going to be file for us simply. And even there are like from the big data point of view, it is not the core of the big data, but there are some technologies. We have something called HBase and then Cassandra. So these are known as NoSQL databases. They can also help you to store the data. They can work perfectly on Hadoop itself. So it is and this I'll talk it later, not important now. So this is called columnar. Both are called columnar databases. This is also columnar databases. And but these are all again from the Apache only. And Hadoop is initially, now it is incubated from Apache, and then lot of like development support, and then everything is supported by Apache only. So that is the reason generally we call it the Apache Hadoop. And from the storage point of view, and this is purely storage, file system based storage. And if you ask me in Hadoop itself, are there any components, software components which can help you store in a different way? We have something called HBase and Cassandra. Both comes under NoSQL, and which also stores data in a columnar format. In a NoSQL, I can give you detail, but right now not required. And even if you ask me, is there anything something similar to SQL kind of thing? So recently there is something in a market, Apache Kudu, which works similar to SQL. Not 100% SQL, but still it is an incubator. It is still growing actually, and that's okay. Those are all very far away. Okay, so at least basic level. This is still not outside. Don't need to worry about. At least these things are very common. There are other NoSQL also, not part of this one. We have something called other NoSQL databases, MongoDB. So this stores data in a document basis, okay, and but this is not a Apache, and this is completely from a different vendor organization. So that is the reason I am keeping it. But mostly people will talk about, when people talk about NoSQL, they talk about HBase, Cassandra, and all. These are two from Apache only, but this is from the company by name MongoDB only. And then there are many more also, but from the open source point of view, these are the very common things. Okay, so this is storage. Storage means you give any information, I can go and dump it. Like you have some money, you want to go and then you have like 20 pairs of the dresses, 100 pairs of the dresses, I want to store. Means you take it and then put it in almara and lock it. Storage means only just preserve it. But once you store the data, let's say you have 100 pairs and then you kept in almara and locking it. Is there any use? You have $1 billion, you kept in bunker and then locked it. Is there any use? It? No use. So generally, why do we need to store the data? We need to use it. Then only there is a benefit. Otherwise, why do we need to store the data when there is no use? So the next important is processing. The main purpose of storage is, one purpose is sometimes we have to keep it for future purpose. Even future also, why we have to process it. So ultimately, whatever data we store must be processed. So right now in Hadoop, we spoke about HDFS, and these are all completely different technologies, NoSQL technologies. So now we need to process the data. So how do we process? So this HDFS, whenever we are planning to learn from the technical angle, when you talk about HDFS, mostly you need to have some basic knowledge of Unix, Linux or Unix, anything, and it processes the data completely in a distributed manner. If somebody talks about HDFS very high level, it is a distributed, it looks very similar to Unix and nothing. But everything, it stores data in a file format only. There is no other way. If you are looking something else, you can go for HDFS and Cassandra. Okay. Now processing. So now you have data in HDFS. Okay. So now this data I need to process. Since it is going to be, HDFS is going to be the very much distributed. Okay, say for example, now I bought some systems and I want to store some data, and depends on your storage limits. Okay, you can buy as much as servers you want, and then you can keep it together. So now I bought 3 laptops, and one of the beauty of HDFS is that when you are installing any software, I can buy any hardware which is available in the market. This concept is known as commodity hardware. What is commodity hardware means? Say for example, I am not sure how many of you heard about Teradata database, Oracle Exadata database, IBM Netezza. If I want to buy Teradata software, generally if I want to buy Oracle, normal Oracle, I can buy Oracle software. I can buy one server from the Dell or AMC or IBM or HP. I can install it. I can buy whatever hardware I want. I can install the software. But if you go to Teradata, if you ask for software, Teradata software they will not give you. They will give you Teradata server. Teradata software will work only with one particular hardware only. This has to be installed only that particular hardware only. And means they will give you software and hardware together as a bundle. And you cannot install it on any other hardware. Even if you want to increase it, you need to go to Teradata only they will give you hardware. Since both are coming from Teradata, whatever cost they say you have to bear. Even the same hardware with another brand coming cheaper, I cannot use it. So that is how they become monopoly. Those are called appliances. But whereas in Hadoop, we don't have that problem. Commodity. You buy HP server, you buy Dell server, you buy one of the cheapest dead cheap server which is available in the market, it works. So that way cost is going to be very. So that way depends on your volume, how much you want, you can keep adding. Right now 3, later 100, 1 lakh minimum. If you go to Facebook data center, there will be 10 lakh servers. All are very cheap hardwares. Cheap means cost wise. Okay, not throwable. So once you have the servers, and we are going to first store or install HDFS, that is just now we discussed about storage. The first thing is in your machines we should have HDFS. And this is from the storage point of view. You can keep anything, but everything is file. And then in case you are looking Cassandra, MongoDB, they can very well placed on this. Sorry, not MongoDB, Cassandra and then HBase. So you can keep them in case you want. If you want, you can keep them on this. And this is a different branch altogether. So now I have kept some huge files in HDFS. I want to process it. That is the second one, processing. So who is there to process? In HDFS, if we have the data to process it, we have a different programming framework which is known as, what is that framework? Everyone knows. Yes, right. MapReduce. So yarn framework is on top of HDFS. You are right actually. They work together. Okay, but the processing point of view, I will take MapReduce. Okay, people in older days means still also. Once you have the data, to process the data which is there on HDFS, process means okay, now I kept lot of data. I want to find out how many number of customers we have, and I want to find out what is the total amount of the transactions across countrywide. Anything, or I kept some huge amount of the Twitter data. I want to find out what are the tweets, okay, about a particular subject. Anything you can call. If I want to process it, I want to write programs in a MapReduce framework. What is framework? Like a template. Template is nothing but let's say simple way. What is framework or template means? Say for example, we are students coming to institute, and I want to take your data, your name, address, and all. If I give you one plain white paper, you can start name, address, and phone number. You can start phone number, name, address. Everybody giving me the data, but it is not in a proper format. If I want to make it proper, I will give all the headings here, name, dash, this dash. That is become a template. If I give you, you can fill it properly, I can take it. Here also, to write programs, there are certain guidelines given. How to process data from HDFS because it is a distributed. And lot of good facilities we have in HDFS. To get those facilities, to accommodate those things and then write your program to process your data, some guidelines, template kind of thing is nothing but a map reduce. It is influenced by some functional programming. Okay, and there is a concept called procedural language, functional programming language. They are the different concepts actually. And in functional programming, we have only two words. One is a map and reduce. Based on that, it is influenced. And but MapReduce being as a framework, when you are writing program, I can use any one of the programming language, Java, Python, C, C Sharp, or anything I can use, but very popularly we use Java or Python. So in case if I want to process data from here, I need to write Java programs in a MapReduce framework. In case you are not interested in Java, go for Python or any programming, but everything is programming only. But you know it's very, but initially if you look at Hadoop was only used by very top companies, okay, Yahoo, Google and Amazon, these top-notch companies, where technology, people, even every engineer and people are a middle level engineers also, they are very much comfortable experience in programming languages. For them it has become very easy. But slowly as Hadoop popularity has been grown into other society, other technology and another IT industry as well. So people started finding difficulty to write a program because Java means everything. Writing a program very lengthy and getting that skill with writing MapReduce framework is very tough. And even if you want to make changes, very tough. The programming languages are very lengthy always in terms of the time, complexity, everything. So that is the reason to make these things very comfortable to outside world. Rather than you developing programs in a MapReduce by writing lengthy programs, there are some other technologies introduced, which is something known as Hive. So what Hive will do? Hive simply scale. Yeah, when it comes to the processing side, we spoke about MapReduce. MapReduce means Java. We should or we must have little bit of good Java knowledge. If you want to really expert, you should have good Java knowledge. And now we are talking about Hive. So rather than you writing MapReduce program by spending a lot of time, So Hive is completely SQL. If you know SQL, you know Hive 80%. So you can write SQL kind of, it supports something programming structured query language called HiveQL. If you write HiveQL, those queries will be internally converted to MapReduce. You don't need to write MapReduce. Hive will convert your SQL into MapReduce, then it will process your data. So that it making your life easy. So nowadays, that is only after introduction of Hive and Hadoop, Hadoop popularity has grown to like anything. Earlier it was not widely used actually, because it is a very basic SQL. And apart from Hive, similar to this, Hive will not store any data. It is only processing, and we have something called Pig. Supports Pig Latin. It is pure SQL. It is kind of a PL SQL kind of thing. Pig is completely now gone. At least now we are in Hive. Both will convert your whatever programs you write there into MapReduce, and MapReduce will be executed on HDFS. But both internally, you may not be writing MapReduce, they will write for you on behalf of you. But here you will be writing pure Hive QL similar to SQL. Here you will be writing Pig Latin programs very similar to Pig procedural programming kind of thing. Okay, but both will be very easy there. So now, if you talk about core big data, sorry, Hadoop, these are the technologies are going to be there. Very basic. This is the storage point of view, and this is from the processing point of view. Okay. So now, I want to store data. So far we are talking about I can place the data, I can process the data like this. And recently there is something called Impala also, which is introduced or developed by Cloudera. It is some people also use Impala, but it is nothing but it is also influenced by Hive only. So you don't need to specially talk about this. But it is not by Apache. So that is the reason I am not keeping it. But in case if anybody asks, Impala is equivalent to Hive. It is like LG and Samsung mobile kind of thing. Everyone has its own kind of features, but we don't require it. But still, I am keeping it for your reference. So these are the code. Now, how do we store data into HDFS? So we are. I am saying that everything will have to place as a file. But how do you place data into HDFS? One of the ways, if you have some files, there are some commands called HDFS commands. Using them, I can place it. But every time using them not possible. That is the reason. Say for example, I am running a company bank. In my bank, all my ATM transactions data is in Oracle here. All my ATM transaction data is in Oracle. This data I need to move to HDFS. So to support it, we have some technology support called Scoop. Scoop is again a different software in Apache itself. It can support to ingest, this is known as data ingestion. It can help you to ingest data from your RDBMS to HDFS directly. Even it can also help to go to HBase as well. So this is called data ingestion. If you say Hive, Pig, this is your scoop, data ingestion. So you have something tables, all these RDBMS data can be pushed onto HDFS. This is one side. In case if your data you want to process in a live streaming. Streaming means continuous data ingestion. Let's say a simple example. Yeah, let's say you have some Facebook data or Twitter data. Twitter means continuously for every given second, feeds will keep on posting. And that continuously I need to keep on moving to HTML. That is called streaming. To support streaming, here generally we leverage some software tools called Kafka. So this can help you to get the data from any source, and then real time, this is called real time. This is a batch ingestion. Ingestion means getting the data. This is batch means hourly basis, minute by minute basis. But this is a continuous, real time. What is the source for? It can be anything. As long as that is able to produce, give you the data, it can pick up and then load it. So these are the things can move data to you, your HDFS. These are the things can help you to process the data. This is the overall core Hadoop. And apart from this, you will get something called Woozy, which is a scheduling, and there are other things. Those are all additional basis. Okay, even if I see if I show you the technology, even I can list out 10, 20 technologies as well. But those are all on need basis. But when somebody says core Hadoop, these are the technologies minimum, and Woozy also will be part of this. Woozy is a scheduling tool. If you don't need scheduling, you can ignore also. That is the reason this is not a mandatory. So overall, if you at least know this, you can say I know big data. One is a processing and one is storage and how you store it and all. So this is core. So what is that you do from the big data? What is big data doing now? Storing and processing. But why do we process? Ultimately, there are two benefits I can get from this. One is I have company running for last 50 years. All the company's data I need to keep. I can store it. Once it is stored, I can process it. But why do we process? To perform some analytics. The main purpose of the processing is to perform some analytics. What is that analytics? I may ask any question about this. Okay. So I get some data. Let's say take Amazon. I want to find out in the last 1 month how many number of products have been sold and how many times these products have been rejected. Means cancelled orders. Anything, it can be anything. I will ask you some question and you can write a query in Hive or you can process through MapReduce. You will get a result and that result we need to visualize it. Give in a proper report format. That is called analytics. So all these tools will not provide analytics. They can help you to provide the data required for your analytics. So how do we do analytics? You can leverage any tool like these kind of tools, Tableau, or so these tools will not give you any graphical representation. None of the tool. Even if I write some query now, the result will be again, you will get a result that you can store as again file only. But in case this data, if you want to visually represent it, you can use any analytical tools, reporting tools like Tableau, ClickView, Kibana, Cognos, and OBIE, business objects. Almost all tools, but these are the top tools. We are very much familiar with big data. So they can directly connect to this. I can directly connect Tableau to Hive, get report done, or I can send this output, this result to outside, and then Tableau can generate a report. Depends on your architecture, will decide it. But generally this part is a visualization part. To do that, we need a reporting tool. But in a commercial companies, we do any one of the reporting tools. That is analytics actually. So the ultimate goal of big data is to generate analytics only. If you don't need analytics, you don't need to come to big data. If you want only storage, you can just buy some tape drives and then store it, because that also save your data. But here we are storing the data to perform analytics. That analytics will improve, you will get a lot of benefits from the analytics. So mostly this use case currently, initially was only used, okay, to replace data warehousing. So in before Hadoop, okay, there were some concepts initially, something called data warehouse. Data warehouse means it is a warehouse of all your company data. From that we generate reports, and in the warehouse generally our data will cross beyond terabytes and petabytes. So rather than using that, all the data warehousing projects are now getting migrated to big data, so that I can do all the things very easily over here. So currently in industry, most of the big data use cases are being used to replace your data warehousing projects earlier. Data warehousing also actually meant for storage and processing and analytics. Earlier these Tableau, ClickView were generating analytics from here, but now mostly we are moving from here to here. Other side, since we have Cassandra, HBases, which are all NoSQL, even if you are building any mobile apps or if you are building any complex application, and they can use these softwares to quickly process the data and all. There are a lot of differences. What has been technically, if you compare, lot many things come. I'm only giving you high level technology names. If you ask me technically compare Cassandra, HBase and all that, I can give you 20 points. But right now not required. So overall, currently big data is in this state. Okay. Now, as generally we never happy with certain things. Always we look for improvements. Even currently also in the big data world, we are happy so far, but still we are finding some difficulties in processing the data. So that is the reason now there is a new technology introduced which is known as Spark. Okay, Spark has a lot of modules, okay, and in which again similar to Hive, Spark also it is a processing engine only. It will just process the data, you will not store anything. And what are the things it can do is, it has two very specific modules which are called core, and it has something called Spark SQL. This will run when you use these modules, and when you process your data, this Spark can directly process your data from the HDFS. We don't need a MapReduce. It can directly process the data from your HDFS. And if you use Spark, it is going to run 100% faster than your MapReduce. We don't need MapReduce framework, we don't need Java or anything. And if you use Spark SQL, you can write basic SQL, how you write in RDBMS, and it will get the data for you in a 100% faster manner. That is the reason nowadays everybody talking about this Spark. So now people are saying goodbye to MapReduce, Hive. People are welcoming Spark now. And the only thing is, when you are doing Spark, Spark is a processing engine, and it can run on HDFS. Yeah, I'm coming. Hive SQL will process the data, convert into MapReduce, whereas Spark SQL will run on the HDFS directly, one of the major thing is it processes the data in memory, which is not there in the why it is making 100% faster. The reason is it processes the data in memory. It has its own engine, and while it is processing, it will process the data in memory. So that is the reason it is lot of benefit. But technically, in the Spark, I can tell you there are a lot of other things also. It makes Spark SQL run better, and it also can run on outside normal operating other servers also, because Spark being as an engine, it can run outside. It can run on an HDFS also. And but when you are using the Spark code can be written using 3 different programming APIs. One is Scala, or I can use Python or Java. So I can use
by using this part, we can insert the data into HDFC.
We can insert means like files we can
unstructured.
Not unstructured. JSON formats up to semi-structured we can format. And if you just want to put, if you want to keep some unstructured, you can give it processing, not possible from Spark SQL. But there are some caveats I can tell you. If you are using Spark SQL, may not good for unstructured. Still using Spark core, we can do some sort of unstructured programming. But Spark SQL, it is not comfortable for processing unstructured data. Similarly for Hive also, unstructured not possible. Because for unstructured data we cannot. But how, if you ask me like I have unstructured data, so we can do some programming. We'll read it from here and then we convert into structured and then we'll ensure that it will be processed in Spark SQL. But whereas Spark core can process, if you give some data, it can process and then you can convert into structure and then use the Spark SQL. Even here also, we have some unstructured data, and I can do it. I can refine it, transform it to structure. Then I can use it with Hive. Even both cases same, because they are always SQL requires some proper structured defined data. But semi-structured directly supports JSON and Parquet and columnar, and then your NoSQL kind of things, it is supported. If you have completely unstructured data, you have to leverage this, make it structured. You have to leverage this, make it structured, and then okay. So this, when you are writing these programs, either you can use a programming language called Scala, Java, or Python. You can use anything. But mostly people will prefer Scala. The reason is the Spark engine itself is developed using Scala. So that is the reason most people will prefer Scala. Otherwise, some people who has expertise in Python, they can also use Python. But Java, very rare. So when you are only talking about the big data processing, these two modules, almost we can go, rather than going to Hive, we can go these two. And only thing is, if you are unstructured, I can use core Spark and make it structured, then do this. And even here also use this, make it structured, and then use it for everything. Now I'll tell you, if you have unstructured data, nowadays we are not even using any one of the things. We have a different concepts to use it. Okay, that I'll come in a next part. I mean, so the data science. So this is the basic thing, cutoff, I can say. And all these things can help you to store, process, and then generally provide everything. Even Tableau, we are also giving the connections to Spark as well. Even in the Tableau itself, if I go to Tableau, I can see even still connections to Tableau. Say for example, so now I have some. This is your visualization. You can see this. It has all the connections. So analytics means finally making your data present in a reportable format is your analytics. So now we'll be moving to second half. This is part 1.
So what is the
This is a Tableau reporting tool. So mostly, most of it nowadays it is becoming wider in use because showing graphs, reports very easy in Tableau. So mostly people are nowadays they are using this. Even we can create it. You can even you have data in Excel, I can create it. Even if you have something anywhere, whatever it is, I can create it.
So actually, developer administrator has to do
Tableau not. If you have expertise, you may do it, but otherwise not.
different team will do it.
But team will be there. People, let's say for example, you already have expertise, you may do it, but you'll have a separate report. But this is your end product. See, all these techniques, a big list of why it is very widely used. So Spark SQL means I can generate the reports directly from the Spark SQL. Splunk, Teradata, it supports everything. SP Vertica, this is a in-memory columnar database. Tableau, Amazon, Vector, everything. Ultimately, our end goal is to generate reports from here. Even JSON, everything. Okay, so now let's see. This is all one set. Storage, processing, and generate analytics. And now I can use core and SQL. All are same actually. So whatever we discussed so far is all about talking about analytics. Means ultimate goal of your processing storage is analytics. Now, when you take analytics as a topic, very high level, forget about storage processing. Analytics means I showed you generation of the reports and all based on the data which we have here. When you take analytics as a topic, I can group into two categories. One is batch analytics, real-time analytics, advanced. This is also known as explorative analytics. So mostly, so far what we have done was, we are taking the data, placing them and processing the data and then generating the reports. Maybe, let's say a simple example, I am running a bank and we have like some 20,000 branches across globe. All ATM transactions and all the bank data I am giving big data and I am using Spark SQL or I am using Hive and writing a query in every country, in every state and from every ATM machine, how many number of withdrawals happen. Or in every country, in every city, every branch wise, what is the total deposits? So you can write a query because you have the data. I can, whatever result I get, I can put it in a Tableau report. I can show it. This is the normal analytics. This is called batch analytics. Means we have some data. Based on the data, we are generating the reports. We have some data. Already data is there, and based on that, whatever is there, I am showing you. That's all. Is there anything I am getting new? Maybe I am calculating into a different format, but your data is already there. That is your batch analytics. What is real-time analytics? So I can do batch analytics from here because you have the data, write a query, get the result, and then use any reporting tool again. Real-time analytics means maybe some information I want to, as soon as, let's say recently last half an hour, what are the ATM transactions done in Hyderabad city, I want it. If you are using real-time ingestion, provided if you are using real-time ingestion, your data, you will get it here, you can generate the report. That is also possible. Provided you have data coming. If data not coming, I cannot do it. So these are the two very common analytics. Generally,
report on transactional data.
Report on transactional data, report on anything possible. Now, what is advanced analytics means? Mostly the moment when we say advanced analytics, the topic comes which is known as predictive analytics. Say for example, now we have a lot of customers in the bank. He has a credit card, and for last 1 year he has been using credit card. Now batch analytics will tell me so far what is the total credit limit he utilized, how much he paid, what is outstanding. All this information I can get it because it is there. But now company is looking lot of losses because many of the credit card, like out of 80% of the or like 50% of the customers who are using credit card, so they are becoming defaulters and then they are getting into losses. So now your manager came and asking you, is there any way? So now these are the 100 customers I have. Is there any way we can predict whether these guys are going to become default? I am not asking for existing whether you are a defaulter or not. I am not asking that. In future, whether you can become a defaulter, I want to predict. Okay? Or say for example, there is a big company, and if you see B2B transaction, let's say for example, there is a big company going to bank and then taking the loan. Let's say we have a Dell company, Dell Lazo company, it went to HDFC Bank asking for a loan. So HDFC Bank want to see what is the strength of the Dell, whether I can sanction 100 crores loan or not. Right now it is doing good. Right now potentially the Dell is very good. But if I give 100 crores loan, after 1 year or even 6 months, will it be in a position to repay the loan amount? I want to predict the future of this. So that is all predictions. To do this prediction, generally, all whatever we discussed will not help. You have the data, based on that you are doing some calculation, generate the report. But whenever there is something coming, advanced analytics, one of the best example is predictive analytics, prediction. And that prediction, to do it, we need completely different set of technologies, tools, everything completely different. But what do we need for prediction? To do prediction, generally we need machine learning, popularly known as ML. So predictions cannot be done with writing SQLs and all that. To do predictions, we need to apply some algorithm. Let's say, what is the total credit card transactions he made? I'll say count something, I'll get it. But to do predictions, we cannot use them. We need to apply some algorithms which are called machine learning algorithms. What is there in the machine learning algorithm? Simply all statistical. Starting from your 7th to 8th class, whatever statistics you learn, mean, median, mode, regression, maybe in engineering and then your plus 3, lot of mathematics we learn. Generally, we don't see the real use of them. There are lot of algorithms on the regression. But all the if I really want to write in a solution in a paper, five A4 size papers, I need to fill in the mathematics. So, if you want to predict something, we need to push this data to machine learning algorithms, and then based on those algorithms, we can predict the data. So there are different types of analysis will be there. Regression, classification, clustering, many more things are there. They are all part of machine learning. But what is there in the machine learning? Lot of statistical algorithms. If I give you some data, you have very patience, you can write an algorithm and then you can push data and then you can do it. But that algorithms writing itself will take lot of time. So, the moment when we talk about the predictive analytics, what is the mandatory thing is ML, machine learning. But what is there in the machine learning is statistical algorithms. But why they named as a machine learning means, say for example, now just to give an example, I have some customers. 1, 2, 3, 4, 5, 6, 7, 8 customers are there. So this customer is a default. He has a lot of attributes, name, address, gender, income, everything. We have a lot of column. And finally, this customer is, let's take, we are all prepaid customers in Airtel. 8 customers have. So this customer, all that information I have, your ID, name, gender, how many times you have opened, when you, all that. And finally, this guy closed the account. So like this, we have all the customers data like this. Status is also known as churn. Okay. Now, based on these existing customers' behavior, you apply these machine learning algorithms. And now, if I give you a 9th customer, all the details, based on this pattern, you should tell whether he will be immediately closed account or open or still. What is the status of this customer in future? So generally, this is called training and prediction or test. This is the concept of ML actually. Means if we have the data, this data, we have to take some data for training. Who is going to train? Not we. Your machine, your algorithm is going to train with all this data. So to make the behavior of this information to your algorithm, we'll apply ML algorithms. Means your machine, your software, machine means software. Software is going to understand your data. Means we are training our software to understand this. Based on that, we are predicting for the other customers, other things. So that is the reason. Generally, here we call it as a machine learning. Your machine, your software is learning your existing data. Based on that, it is predicting for you. That is the reason it is called machine learning. But what algorithms and all that, are all typically statistical algorithms. So this is actually predictive analytics, machine learning and all that. But let's say this guy is there and then writing some Java program and all that, you know how to calculate it. But if you ask him to write some regression, linear regression algorithm, or like coefficient of a particular information, you need to write a lot of lengthy program. It is not that easy. So that is the reason to apply these algorithms to process your data with these algorithms. There are some specific technology tools developed exclusively to use these machine learning algorithms or apply these algorithms, and these programming languages are specially designed for them. One of the best example is R. R is a programming language. It is specially designed to apply ML algorithms. R is a programming language, very easy. And similarly, there is a very, I can also use Java. There is nobody question, if you are able to do that algorithm to SQL, you can go ahead. If you are able to do the algorithm in Excel also, you can go ahead. But that is complex. But R, very easy. And similarly Python. If I use Python, I am in a position to apply these algorithms, predict very quickly, easily, because it has a lot of libraries in the Python. There are some utilities built for ML only. So that is the reason there are very, very powerful programming languages to process your ML. This is one set, and even some research fellows in universities and academicians, even we will also use something called MATLAB. This also comes under this. Not in now, for many years people have been using MATLAB. Now, if you want to go with Python, go with Python. If you want to go with R, you can go with R. But to make with life our easy, in Spark there are two utilities. There is a special utility developed which is known as Spark ML. Spark also has its different module called Spark ML. Even I can use it. So I can use this ML program either Scala, Java or in Python or anything. But if you are using Spark ML, very much what we are doing in a Python or in a MATLAB, I can. And all these algorithms, whatever we have here, can help you to, you can, any one of the things, you don't need to learn all of them, any one of the things can help you to apply machine learning algorithms. Within that, statistical algorithms will be there, and then you can predict, and whatever prediction result you get, again that result we can go and get it into analytics, the Tableau, ClickView and all that. Everything report comes from there only, reporting tools only. Okay. But here, what is happening? This is a very basic prediction matrix. But nowadays, people are asking a lot of things. Okay. Say for example, simple example. Since we are talking about unstructured, because this is very common. We have the data, some predictions can be done. But nowadays, people are talking a lot many things about unstructured data. Say for example, there is a lot of tweets are coming, and from the tweets, everybody as per their interest, they will write some paragraph. Whatever tweet data comes, it is not a structured data. Okay, say for example, now See, so this is Twitter streaming data. So continuously you go and then tweet anything, it is coming live. This program connected to Twitter, you are getting the data and what are tweets are going to happen, the entire tweet data is. So if anybody has a doubt about the unstructured data, this is unstructured. So can anyone find out the structure from this? You can write as maybe if you go to Verma's tweets, it will be like some paragraph. We don't know what is Ramgopal Verma. So from this I want to understand. Okay, I will give you one particular topic or let's say one word I will give you. So for this particular word, what is the feedback from the customer? There is a movie, simple example. For this movie, there is a positive feedback or a negative feedback. That I want to get it. Unless until you read it, we cannot get it. Okay? Say, let's stop it. So now how do we do it? One of the ways, you get your data into HDFS. This entire data streaming, I told you right, this streaming can store to HDFS, write some MapReduce program and then try to do some programming, but very difficult. So that is the reason nowadays there are some different tools available in the market which are known as text analytics and natural language processing NLPs. Means mostly text means normal text. When you are typing is the text only. So text means always a language. People will use some language. So when you use these NLP tools, it can help you to find out, detect sentences. And in every sentence, parts of speech. What is part of speech? Noun, verb, adjective. So if I give you one particular word, I can search and for that particular word, feedback means always adjective. Find out different adjectives associated with that particular word. From that I can find out what is the feedback. Feedback cannot get it from normal theme. So I will good, bad, wow, these kind of things and then we can categorize them. So that way, mostly when you are working on this, you will get lot of unstructured data, but typically that unstructured data we process through NLPs, text analytics. The Open NLP is one of the product from Apache. If you use it, it can help you to detect sentences, parts of speech, and everything. Mostly, we use these kind of software to process unstructured. Though we can talk very high level MapReduce can do unstructured and all that, but in a reality is always very complex. We can do it very complex. But generally, we use these tools to perform text analytics. They can go to the level of understanding the verb, adjective, parts of speech, and then lot many things. So that is the reason we use this one. So all these things together, we try to finally what we are going to do, predictive analytics. Explorative analytics, deep diving, all comes under same category. Explorative analytics means we are going to explore very detailed, deep diving exploration we are doing, not like a simple data mining. One of the example in the explorative or deep diving is, say for example, whenever you go to Amazon or Snapdeal, you buy a product example, immediately pop-up comes. People who have bought this product also bought this. So it is a popping up immediately, predicting. So that is generally known as market basket analysis or like deep diving exercise, explorative analytics. Based on the combination it will do it. Or in a simple data mining, say for example, when you go to any supermarket, people are going to arrange items. If I am a small kirana shop owner, I know what products to keep it first, what products to keep it later. But if it is like a very big shopping mall, Walmart or Central kind of thing, but very challenging to know which products to keep it where. People will do apply these rules. From that, what simple example I'll tell you. Generally, people who are coming to shop, first they are buying a milk. So I kept some milk packets here. When I see the combination, when I did some analysis, I found that every customer every day morning who is buying a milk in the same order is also buying bread also. I got this combination from the query. So this guy went to shop. He is very much interested in buying bread, milk also. Milk is there, but when he search it, bread is not showing. He is hurry. He will go out. He may not buy. But if I keep it milk and bread packet together, so definitely chances are, even he is not interested also, definitely he need it. People, he will definitely buy it. So this is comes under data mining, all with these statistical algorithms, machine learning algorithms. Everywhere in industry, not now, from the IT industry zero level itself, we have all this predictive analytics there. But in the older days, we were using SQL, Excel and all that. But now we are very much equipped software tools which will make our life easier. So all this category, predictions, ML, putting all together will give a simple word, data science. So data science is not a specific technology, like it is a concept of what we are doing here. In that you may use anything. Somebody may do data mining, somebody do, but mostly high level nowadays data scientist job is to do this one. So depends on your wish. You can only use R, you can use Python, you can even very basic mining if you want, you can go with Hive also. It's a very small statistical things. And now advantage of Spark ML is that so it has a very high end processing capabilities so that you can improve your speed. That is the reason Spark ML is very much limelight in industry. And apart from that, it also introduced recently one more module called Spark R. The R is very easy to learn and then develop, but problem is R cannot work on big data on its own. So that is the reason R they have embedded in Spark. So Spark R. I can write Spark programs, R programs in a Spark. So core SQL ML R, and it also has one more module called Spark Streaming. Whatever I showed you that streaming, so this is typically comes under this category. Real-time data ingestion. This program which I showed you is Spark Streaming. And use Twitter, because Twitter will keep, as you keep tweeting, as on the world so many people, as they keep getting the data. That is a streaming example, real-time streaming example. And it has one more thing called Spark Graphics for supporting graph databases. That is a different story. This is the part data science. If you are looking for only data science, you can directly jump onto data science. But if you are planning to learn data science only with R, no need of big data knowledge also. Python also independently works. But nowadays, you can ask me, why people are together mixing data science and big data. Okay, there is a relation. Why? To apply these algorithms, we need data. But the data comes from where? Smaller volumes, I can put it in Excel and take it. But now if you want to get a good result, good predictions, we should apply a lot of input data. If I have more samples, I'll get better prediction. But if you want more samples, more data I need to store. But where should I store more data and then easily process? Big data. So in older days, data volumes are smaller. We were leveraging them, no issues. but we are samples and we need more data, or even when we are doing these algorithms, we need to apply lot of business transformation rules actually. So even to calculate and to process all of them, it is important, mandatory to process it very quickly. So it has something like when you go to big data science, we have something called labeling, featuring and all that. And all the data, whatever algorithms we are going to supply, generally it won't take text, always it will take numerical only. Conversion of categorical values into numerical, a lot of processing will be required. A lot of data massaging is required. This is the reason to give a or to prepare a data feed to your ML, we need lot of data processing is required. If you have smaller amount of the data, I am happily write a SQL, prepare the data. Even smaller, I can take the Excel also. But as we are growing, industry growing, and then industries are leveraging some terabytes, petabytes of the data, and as you have more data volumes, as you have more samples, the better prediction. So we are inclined towards taking the data from the big data. We are switching over from the traditional ML or data science to big data science. And for that, Spark ML is a better solution because it is a distributed, it has tight integration with HDFS processing, so that your processing will be speed, your ML algorithm execution is speeder, everything speed.
When you are talking about HDFS, does it mean Cassandra and Express also?
No. When I say, if I use a word purely HDFS, no Cassandra. No. And one thing is, Cassandra HBase can also be sit on top of your HDFS internally. If I use HDFS, I am directly talking HDFS. When you say Cassandra, internally it may sit on HDFS or it may not sit. So that is internal. But it can also sit on HDFS.
So big data, Hadoop can run even without HBase or even without Cassandra.
If I am not interested, you throw it away. That minimum HDFS is.
So here no database.
No database, only 5.
Without database they can use.
Even this, it is also not 100% database, no SQL. It is again different section. But if you are talking about the kind of a SQL, there is a kind of regular database kind of thing. We have something called Kudu, Apache Kudu. It is Apache Flint. Lot of things are coming, but this is one of the best one. So
this Scala ML,
Spark ML.
Spark ML they work with Cassandra and Express also.
HBase also. Because Spark can process from Cassandra, it has a interconnectivity, so it can work on that. So if you are looking on core big data side, your scope will be towards this. This is your scope. So I am just tweaking out this up to this part. If you are only talking about core big data, your scope will be up to this part. And when you are talking about the data science, if you are exclusively talking about the data science, this is going to be your scope. ML. Intersection always there. This the Spark is there. So why I have not given intersection is this you may link to this HDFS with a Spark internally connecting to this HDFS. Because if you are using R is not distributed, so it cannot work on HDFS independently. Python programming language also independently will not work on distributed file system. MATLAB also not. But Now Spark R can be distributed. Same R programming, if you are using with Spark, is distributed. Spark ML is purely distributed, and if not, other things. So the processing you can use any one of the things, and basic if you learn almost it is same. But you can prefer Spark ML nowadays because it will indirectly cover all of them. Which one? This one. This part. Now, so big data part. If you are not looking for data science, this is enough. If you are only looking for big data, not looking for the data science, retrieval, MapReduce, Hive, and all the basic other things will be more than enough. And it depends on the need-based NLP. As we discussed about the Open NLP, this will be there here or here, depends on the requirement. You should have an interest of learning that. But mostly, this is towards data science. There are a lot of data science people look for this one. And big data always talks about bigger volumes and processing. ML talks about data science, always talks about the predictions and all that. And also, there is another community also. Even, let's say for example, everywhere why big data is coming, this is very high level. Because this part I told you, volume, variety, velocity. This part is machine learning, very advanced. Apart from this, nowadays you see every startup company, they are depending on big data. But when you say startup company, do they have that much volume? And maybe definitely they need ML. ML is there required in every company. Even if you don't have volumes also ML. Okay, everywhere ML is there. A smaller companies, bigger company. Let's say you are using, suddenly you will get some mails or suddenly you get something, okay, offering, as I told you, right? Even if you are building a small e-commerce company also, everywhere ML we are going to use because we discuss a lot of use cases. Still, even if you are not using ML also, still smaller companies are going with big data. The reason is NoSQL. So NoSQLs, very high level, they are like, they store data in a document format. Columnar. So mostly they support data storage and processing, not for the bigger volume. To some extent, storing your semi-structured data and processing very quickly. Even if you are building a small mobile app or a small web application also, nowadays everybody is planning to depend on these NoSQL databases. Because generally these are all schemaless, especially if you see document type database MongoDB, schemaless. Mostly from the Java background people, or mostly they are planning to learn the MongoDB because it supports data storage in a document format. Okay, the reason is, what is the complexity is, if you see nowadays, if you notice any website like Snapdeal, Amazon, all big e-commerce companies, you never see screen similar every day. Every day it will keep up. Means it is now we are in the world of dynamic schema changes. Your business process will never run same. If you see last example, in a demonetization phase, government rules have been changed every day. And if I want to accommodate those changes in a website, first of all our Java programs, everything, whatever you are writing, they take data from tables. So your table structure, as per that structure, you are writing your Java code. But if you want to make some change in your business process, first of all, your table structure should be changed. And then as per that, you have to change your code. And if you want to do these changes on a daily basis or a weekly basis, and if you want to follow complete software SDLC life cycle, it is not possible. Test, develop, test and all. But if you are using schema-less databases, like these kind of things, so the entire table structure and semi-structured data will be stored as a file. So when you are reading, even though there is a small change, and without changing your database structure, we can programmatically make everything changes. Like everywhere, if you look at complex databases, and changes structures will be very, very dynamic. Sometimes daily, weekly, and monthly as per that. So that is the reason most of the people are depending on NoSQL databases, even to build a small mobile application as well. And on top of that, because even small apps also providing lot of features, and that is all based on ML only. Without ML, we cannot get any feature. So that is the reason this area is even needed for even small, bigger companies. But core big data, when you talk generally, if there is a bigger volume, then only we need it. That is the reason lot of demand for data science. Now big data has become normal nowadays. Now it has become like a Oracle database only. Everybody, because now we have a skill Hive, right? People are HDFS little bit of Unix, and MapReduce I learn basic things, but have a Hive I can process it. So it has become a very common now. So people are looking for a lot of data science people, and who can do, because it can generate a lot of revenue for your companies, because this is the critical thing for them. Statistics level, we need, if you, I truly speaking, if you have a good knowledge on statistical algorithm, that will help you to become or master data science. You can also manage with a small portion of data statistics also, but you will have a trouble in understanding. You cannot become a master, but I will cover all the statistical things required for this. You don't need to worry, because a lot of statistical algorithms are that, but we don't need all of them. But from our predictions point of view, whatever is required, we need it. That is the concept. Last 1 minute, one thing I need to tell you. So far we spoke about big data, data science, and ML, and NoSQL, lot of things. And mostly you might have heard all these technology names as well already. Apart from that, you will be keep hearing about something cloud era. Many things. So any idea what are these? Yeah. So if you look at Hadoop, who developed Apache, now it is the incubator project of Apache, and a lot of open, it is being is open source. People are contributing. Even if you want to contribute, you can contribute. So, but that is the brainchild of this Doug cutting. So if you go to Apache website, the complete whatever list we have discussed, you can download, and then you can install, and then you can work on it. It is free. So Apache, Apache.hadoop.org.apache, you can search it. Okay, you can download it. But now the problem is, being it is open source, if you have practice purpose, okay, I am running a very big bank. I am running. I am planning to implement big data. I downloaded and then running it. Suddenly there is a problem in the software. Not the program developed by me. The engine itself has some problem. Where should I go? So I need to troubleshoot, sit, and then open the source code and then start troubleshooting, because there is nobody there to help you. Maybe Google it, somebody you have provided some solutions. Otherwise, you are completely stuck. So for commercial companies, using the open source is slightly risk. Because I kept all my data here and software is not working. Not the program, software itself not working. You are stuck. But in the same case, if I use Oracle software, what I can do? Oracle software completely now failed running and I am not able to troubleshoot. What I can do? I can go and ask Oracle, they will come and then rectify it. For that they will charge some supporting cost. So that is the reason what intelligent people what they have done to make the market money. They have taken this open source and on top of this open source they developed some additional mask makeup in other way simple. Core is your Hadoop only, but on top of that they will keep their own controls, layers, masks, anything whatever you call. And then they will sell this masked product as their own product. And for that they will charge a very minimal cost. Whatever they are developing this circle, charge will be very minimal. And if you use that software, if there is any problem, they will come and rectify. How these layers are going to help back-end logging, what went wrong, and they are taking complete software in their control. And using their logs, they can know what went wrong and all that. Even they have expertise because they are spending lot of money in their R&D. So they have expertise, they can come back and then quickly rectify it. So these are called distributions. Apache Hadoop is a open source. Apache is a open source. All are Hadoop only. Apache Hadoop is a open source and remaining all proprietaries of their own. These are the company names. So that is the reason when you say I am learning Hadoop, first question I will ask you, which distribution you are learning? Distribution is which vendor? Apache, Cloudera, Mapper. Whatever you use it. If you go to Cloudera, they will give you this. If you go to Hortonworks, they will give you this. And but inside core is same. So if you learn any Hadoop, everything is same. Only thing, some extra administration, management layers will be different. And that is for the administrators. People who are learning for administration. So you should learn first core understanding and then depends on which distribution you are learning. You should know how to perform administration for that particular distribution. But almost looks very similar. They don't have any challenges over there. So very famous distributions are Cloudera, Hortonworks, and Big Insights also good, but it is very costly because IBM always very richer. So nowadays that is the reason people are not going much with IBM, and nowadays Microsoft also got into this. Earlier these Hadoop distributions were not working on Microsoft Windows, so now they have come up with a different distribution, and they are simulating Unix layers on Windows and then installing Hadoop, but that is not very famous. Generally nobody going, but again Microsoft comes into licensing and all that. So this is very famous, and Hortonworks also completely full available in Apache. They made it completely open source. If you download, you will get complete Hortonworks into your system, no support. But if you buy it from Hortonworks, they will support you. Without support, complete Hortonworks, if you want, install it, no legal compliances. But if you need a support, you need to restart from it. Apache complete open source, no support. For Cloudera, to minimum version it is free only, no complication, and support again cost. Mapper bit from the beginning itself we need to pay license. Big Insights anyway very higher end in terms of the cost. So when you are learning big data, you can prefer any of the distribution, and here we prefer Cloudera. And from the data science point of view, I prefer Spark ML, and then if you know Spark ML, almost after Spark ML will cover both Python and R also. If you know one programming language, statistics are same, everything is same, only the code is different. So we'll give an overview on Python and R, both will be covered. And depends on the time and all that, I'll maybe give a walkthrough on OpenNLP. If you have, that is good. Otherwise, it's okay. Almost done. So this is Hadoop and then big data embedded in Spark, how it is placed. Now you know everywhere why only big data is come. Big data storage point of view, very few limited companies only who need higher volume. But data science needed even for small company also. And depending on that, you can. And advantage of the Spark is that Spark engine can work on normal system or HDFS system, non-distributed system and a distributed system. See here, Spark. Currently, Spark is running here. Where is it is running? It is running on my machine, where this is a Windows. And I am able to get the Twitter streams.
It is like stable and some idea.
No. Spark is engine. You will write a code in.
This is the Spark code. It is similar to
Java. And there are three programming areas: Java, Scala, or Python. And Scala, Python are bit easier one, and Java is bit lengthy one. See, this is running. Spark running. Spark streaming is running, and is connecting to Twitter live now, and then getting the data on my Windows. And if you look at this, this is your Cloudera. So if I go here, see the streams are coming. The same program I can make it to work on Cloudera or HDFS, and then that it will store on to HDFS machine.
In business industry, where are using this data science?
Everywhere. I gave a lot of example. So do you have any domain knowledge? I'll tell you that example. Banking. Okay. So we took same example. Say for example, we have some millions of credit card customers, and I want to two things I want to find out. If it is a normal customer, I want to find out customer churn, means in future how many customers may drop out from our bank. I want to predict. Or let's say we have some X number of credit card customers. I want to predict how many number of customers may become defaulter in couple of periods or certain X number of periods. Or say for example, when credit card we have some X number of credit limit we have, and bank to encourage people, bank is planning to increase the credit limit. So, but what is to what extent I can limit? Can I increase for everyone 20,000, 30,000, or what is the limit? I need to go and understand your credit usage pattern, your payment pattern, repayment pattern, or how many times there is a lapse in payment or payment option. Based on that, it depends on your income and all that. I need to predict what will be your potential score in future. Based on that, I can help you to increase your credit limit. Or if say for example, now if I predict that this customer is going to be dropout or defaulter, so then I will not do anything for it. And then they will have a stringent payment, like they will push your third party payment collections team to get the money immediately. They will try to close as much as possible. They will not show any interest on it. Or say for example, you are a credit card, let's say you are taking a prepaid or a postpaid. If you see, every company will spend, say for example, $10 to bring or $100 to bring a new customer. For example, if I want to get a new customer, company will spend $100. Why? Marketing, I will call 100 people, out of 100, one will become successful, and all these charges, everything will become $100. Means to bring one new customer, I am spending $100. But what if I am not providing my services properly? If I lose one customer, if I want to bring one more customer, I need to spend one more $100. So if I want to proactively monitor who are the customers who are not satisfied with us or potentially may go outside, again prediction. Out of all these customers, based on previous data, training data, I need to understand what are the customers may go out. Immediately I need to go and talk to them and then give some special instructions to the customer care and then massage you what you want and all that. So that way at least I will retain my customer. Everywhere. Not only that, even if you go to WhatsApp, when you are typing English, immediately our sentences will pop up. Let's say when you type something, you get something. All are from the ML only. That is all parts of speech. Machine learning, data science.
In this context, you are going to use statistics.